In this video, we are going to learn about the heap sort. So we will not look into the detailed working of the heap sort coding wise, but actually we will see what is the main functionality of the heap sort. So first of all, let us learn some terminologies which we will be using in the video. So first of all, we must know that what is a heap. So heap is actually an ordered binary tree. Then we should know what is max heap. Actually, we will be using max heap terminology throughout our video. So max heap is actually, it has a restriction that the values of the parent nodes must be greater than the values of the child nodes. It simply means that if max heap is actually a function, so if you run this function, it simply means that your tree will be sorted in such a way that the largest item or the largest number will be on the top as a parent node. So let us see, we will make use of a few functions when running the heap sort. So first of all, we have build max heap. This creates the max heap from the unsorted array. First of all, whenever we have an array, we just consider that it is unsorted, and that is why we are doing this sorting thing. Then we have a Heapify function. This is similar to the max heap function but faster because it assumes that part of the array is already sorted. It just assumes that. So in this video, I'm less concerned about the details of these functions, how they work and the related questions. Rather, just focus that they exist and when are they used. So we will discuss these in details when we will calculate the complexity of the sorts, and we will be looking at the algorithms in depth. So at that time we will be focusing on the pseudo code. So once you understand the basic idea of the heap sort, you will understand these functions from the pseudo code very easily. So let's get started and see how the heap sort works. So first of all, let's consider that we have an array that is to be sorted. Let's consider this is our array which needs to be sorted. So it is an unsorted array. So first of all, so during this sort, in short, we will continuously do the following three things. So first of all, we will create a max heaps. We will create max heaps to find out the largest item. Then we will remove that specific largest item from the heap and we will place it into the sorted partition. Now, let's think that this was our array and we created this tree. This is heap. Heap is ordered binary tree. So इस array को use करते हुए हमने ये specific tree बना लिया. How this tree is being made? Let's have a look. So we begin by representing our array as a tree. So first of all, look at this. We had the number 2. 2 is being placed. Then we have 8 and 5. So by using the left and right rule, हमने 8 और 5 को place किया. Then 3 and 9, and then 1 is being placed. If you know how trees are made, so you will know कि हमने किस तरह इन terms को pick up किया and we just placed them. So now as we have our tree, let's create our first heap. So we assume that it is unsorted array. So we call build max heap function. अब हमने ये कंसीडर किया कि ये array बिल्कुल अनसॉर्टेड है. सबसे पहले हम build max heap फंक्शन को कॉल करेंगे जो लार्जेस्ट नंबर को उठा के एज अ पैरेंट नोड बना देगा. सो फर्स्ट ऑफ ऑल वी हैड दिस array and this was the tree of that specific array. Then we called the build max heap function जिसने क्या किया, find out किया the largest number. It just find out the largest number. It is 9. 9 is being placed on the top as the parent node and 2 is replaced with the 9. जहाँ 9 था वहाँ हमने 2 दोबारा लिख दिया. So simply you can see that we have a max heap now. यही काम हमने array में भी किया कि array में भी हमने 9 और 2 को swap करवा दिया. Later on, now as we have our max heap, we know that the largest item is 9. So we swap 9 with the item at the end of the array, that is 1. अब यहाँ पे हम देखेंगे कि end of the array पे 1 था और 9 हमारे पास max heap आया. अब ये हमारे पास largest number है. As we know we are going to sort out the array, तो sorting में obviously largest number सबसे end पे आता है. तो हम अपने largest number को एंड वाले नंबर से रिप्लेस करवा देंगे. सो वी विल सिंपली स्वैप द 9 विद 1 बोथ इन द हीप एंड इन द array. So now you can see that 1 is being placed as the parent node, 9 is being replaced. So finally, after swapping 9, we remove it from the heap and considered it sorted. हमने अब ये कंसीडर कर लिया कि 9 एक सॉर्टेड एलिमेंट है क्योंकि वो मैक्सिमम एलिमेंट था, लार्जेस्ट एलिमेंट था और हमने उसको सबसे एंड पे कर दिया प्लेस, तो अब वो सॉर्ट आउट हो गया, तो उसे हमने सॉर्टेड कंसीडर कर लिया. हम अब क्या करेंगे, वी विल रिमूव द 9 फ्रॉम द हीप. यहाँ पे 9 हमारे पास था, हमने उसको रिमूव कर दिया एंड नाउ दिस ग्रीन कलर शोज कि 9 हमारे पास एक सॉर्टेड एलिमेंट है. अब हम जब बाकी सॉर्टिंग करेंगे तो इसको नहीं छेड़ेंगे. वी विल नॉट डिस्टर्ब इट्स प्लेस एंड वी विल not even consider it or compare it or do anything with it. Later on, this time we called Heapify since only the item 1 is out of place. अब आप यहाँ पे देख सकते हैं we have 8, then 3 and 2 are less, then we have 5 and we have 1. अब 1 जो है वो out of place है. If we have this is a max heap or whatsoever, we must have the largest item as the parent node. So we call the function Heapify, and after calling the function Heapify, 1 flows down to the bottom and the largest item comes on the top, and again we have the max heap. Now how 1 flows down to the bottom look like that. Now first of all we will call Heapify. 8 और 1 swap हो जाएंगे. 8 and 1 are being swapped. Then again if you see 1, 2 and 3, they are again not in order. So again we will call the Heapify and 3 will flow up and 1 will flow down. So now this is a max heap. मैक्स हीप हमारे पास क्या चीज़ होती है जिसमें पेरेंट नोड्स हमेशा चाइल्ड नोड्स से बड़े होते हैं. पेरेंट्स नोड्स आर ऑलवेज ग्रेटर देन द चाइल्ड नोड्स. सो नाउ अगेन वी हैव मैक्स हीप. इट मीन्स 8 इज़ द लार्जेस्ट एलिमेंट. सो नाउ लेट्स स्वैप द लार्जेस्ट नंबर 8 with the item at the end of the unsorted part of the array. Now you can see this 9 is in green portion and green portion is sorted part. So हमने सिर्फ इस portion को consider करना है जो 2 से 8 से start होके 2 पे ख़त्म हो रहा है. And now we will swap the 8 with the last place of the unsorted array. तो यहाँ पे हम क्या करेंगे, 2 और 8 को swap करवा देंगे. Now you can see 2 and 8 are being swapped. Now we will remove 8 from the heap and consider it sorted. अब हमने 8 को भी remove कर दिया और 8 भी अब green portion में आ गया. Now 8 is being sorted. So now again we will call Heapify. When we will call Heapify, we will again see that 2 and 5 are not in the place. 2 and 3 are also not in the place, but we will consider the largest item and we will put the 5 in place of 2. So after doing Heapify, you can see 5 is used as the parent node because it is the largest number right now in the heap. So we did Heapify. We have the max heap again. Now we can see we have the largest number 5. Again, this white portion is the unsorted portion of the array. So we will swap the 5 with 1. When we will swap it, we will remove the 5 from the heap, and again 5, 8 and 9 are the sorted portion of the array. Again we will do the same thing again. Now again we can see the 1 is on the top, which is not right, so we do Heapify, which places 3 on the top, which is the largest number. Again we have a max heap. We pick up the 3, we replace it with the 2. Now you can see again 3 is removed and 3 is the sorted part of the array. Again with 2 is already on the top, it is already the maximum number, and we just run the Heapify and we know that 2 is on the top, it is max heap. And then again we do the swapping, 2 is here and we know that it is being sorted. So again by end of this, one is again sorted, and you can see the our whole array is being sorted in this way. I hope you got the basic idea how the heap sort works. So this is the pseudo code for heap sort, or you can say that we just make the algorithm by using this all when we implement it in the coding. And the complexity of heap sort is n log n, and we will discuss how this complexity is being calculated and all that stuff when we will do the detailed analysis of the heap sort. So thank you. Please give your feedback.